Okay, so we talked about letter A in class a little bit. Just a reminder that that is your scale factor. Because something, when you redraw them, you'll notice that the pinks don't both have a number, the yellows don't have a number, and neither do the greens or the browns. So you have to be given the scale factor. So start off with 3 to 2 in both equations. So 3 is to 2 as 12 is to y. And then again, 3 is to 2 as x is to 12. And then you solve it from there. The next one gives you the scale factor of 1 to 2. So I start off with 1 is to 2, and I redrew them both over here. I took them apart and redrew them. So 1 is to 2 is small is to big, so then you can go small is to big. 3 is to y. Start over again. 1 is to 2 as small is to big. 4 over x plus 4. You cross multiply and solve from there. Again, pause this anytime you need to. This one here is an isosceles triangle. If you notice that this side is the same as this side, which means that the similar one will also have the same idea going on there. So if they tell you that the left is 24, but then you're dealing with the right on the other one, well, both sides are the same. So they're both 24 and they're both y, so that helps you match up. All the pinks are going to be related. They're all corresponding. So it's 2 is to 1, big is to small, so big is to small. 2 is to 1 as 24 is to y. 2 is to 1 as big is to small. 21 is to x. You cross multiply and solve from there. Alright, these are definitely more complicated when it doesn't give you enough information and they ask you to use the Pythagorean theorem to find information before you even start the problem. So you really have to watch the screencast to understand this problem. Because if you set this up and you looked, you have 5 is to y, well that's not both numbers. X is to 26, those aren't both numbers. And 12 is to nothing's over there, so there's no ratio you can use, and they didn't give it to you like they did up there. So the only way to bail yourself out and find a third side is to use the Pythagorean theorem. So a squared plus b squared equals c squared. 5 squared plus 12 squared equals the hypotenuse squared. 25 plus 144 adds up to 169. Square root of 169 is 13. So this side becomes 13. I'm going to erase this to give myself some room, but you can rewind it and see how I got that using the Pythagorean theorem. Now that I know that that's 13, I now have two corresponding parts. The blue and the blue I both know. So 13 over 26 can be a ratio. So 13 over 26 equals red over red. Okay, so this problem, one right triangle is hidden inside the other, and they're definitely not sitting in the same position. So I had to redraw them. I'll show you how I did that, where I got to this picture. This was this one. Oh, let me do that again. This was that one originally. So I just copied it over. 6, 3 plus x, or x plus 3, and the bottom is y plus 4. So once I had that figured out, either with patty paper or just with your eyes or even with a highlighter, I do suggest you redraw them, and I put it over here. Then, where did this one come from? This is this right triangle, and I copied over 3, x, and 4. I just kind of brought it down here. So you can see there's sort of, obviously different sizes, but they're reflections of one another. So you can see that the pink goes with the pink, the green goes with the green, and the red goes with the red. But if you look again, just like the last problem, we do know something. We know 6 and 3. We know the bottoms. So 6 is to 3, but after 6 is to 3, we're stuck, because if we tried to do this over this, we would have two variables. We'd have y and x. So our big problem is we need to find out what that x is a different way. And we can use Pythagorean theorem and do 3 squared plus 4 squared equals 5 squared. You don't know the 5 yet, but you're going to in a minute. 3 squared is 9, 4 squared is 16, 9 and 16 is 25. Square root of both sides makes the hypotenuse 5. So we can change this number to a 5. So now we have 6 is to 3 as this is to this, which is y plus 4 over our new 5. Now we only have one variable, and we can cross multiply and solve. And we've already found x, and now you're able to find y. So when you need an extra value and you don't know what it is, maybe you can use Pythagorean theorem to do it. Alright, so the biggest hurdle here is to start off and just draw them. So it says right triangle ABC, so I drew that down here. And it said that AC is the hypotenuse, so I made sure AC was the hypotenuse side. And then I labeled it AB is 8, BC is 15, and AC is x. Okay. Tells you that it's similar to another triangle, DEF, which I drew over here. And if AC was the hypotenuse, then DF has to be the hypotenuse. So I was able to figure out that that's what it looked like. And I labeled it Z, Y, and 51, like it said there. You'll notice that there is no pair of sides that match up. 15 and Y, those aren't both numbers. X and 51, those aren't both numbers. 8 and Z, those are not both numbers. So we're going to have to figure something out. This has the most information, so I can use Pythagorean theorem to go 8 squared plus 15 squared, and then I'll try to find the hypotenuse. So 64 plus 225, add those together. 64 and 225 is 289. Get the square root on your calculator and you'll get 17. So this number right here is now 17 without even having to do any ratios. I'm going to change that to 17. So I'm going to erase this work. If you want to see it, you can play it back. And now I have sort of a new problem with more information than I had before. Okay, so now what two sides do I know? You know the hypotenuse of one, and you know the hypotenuse of another now. So my ratio can be 17 over 51, and then you can go back and do 15 over y. So hypotenuse over hypotenuse, left side over left side. And you can go ahead and cross multiply and solve there. The other one will be 17 over 51 again. So 17, 51, 8, and z. The key to that problem was to be able to find the 17 first using the Pythagorean theorem. Those last three are tricky, but we really have to bail ourselves out and use Pythagorean theorem to find the third side before we set up the ratios.